Happy day, students. So far in this interference and wave optics, we are talking about monochromatic sources. Okay. In the last classes, I told you monochromatic means those sources which are emitting single wavelength. Okay. Now I am going to do a question which is based on a source which is emitting two wavelengths. Okay. So two wavelength sources are called bichromatic sources. Bichromatic source. Okay. So if suppose we have two sources S1 and S2 and both are bichromatic. Okay. Let's say both are emitting violet and red at the same time, simultaneously. And we are seeing on the screen the interference happening over here. Okay. At the center here, at the middle point, if I ask you what is going to happen, whether it will be maximum or minimum, it will be maximum for both violet as well as red. Why? Because here there is no path difference. Path difference is 0 here. So when path difference is 0, phase difference is 0 for both red as well as violet wavelength. Okay. So here will be maximum of both. Fine. Now what the question is asked? Question asked is, find which fringe or which maximum of violet coincides with which maximum of red color. Okay. Which maximum of violet coincides with which maximum of red color? Here, what are coinciding? 0th maxima, both are coinciding here. Other than this point. Okay. Other than this point, at which point on the screen both violet and red maximum are coinciding, we have to find. That's the question. Okay. So let us assume this is the point. Alright, at this point, violet and red certain maximas are coinciding. Okay. Now tell me, is the fringe width of violet and red same? Answer is no. Fringe width basically means what? Beta, and its value is what? Lambda d by d. So if I am going to talk about violet color, then it will be lambda of violet d by d. If I talk about red, it is lambda of red into d by d. And we know that lambda of red is more, so obviously fringe width of red also more. Okay, what is fringe width? Fringe width is the gap between two successive maximums. Okay, so now if I assume here from this point where is 0th maxima of violet, and here I assume that there is NV maxima of white, NV maxima. So that means how many fringes are there in between? NV. Okay. Now suppose I say first maxima, then how many fringes are there? 1. 2 maximas, that means 2 fringes. NV maxima means NV fringes. So here NV fringes are there. Same way I would say for red, there are NR fringes. Okay. Here we are going to have how many, what fringes of red color? NR. Are you able to understand? So in this one, there are NV fringes of violet, and in this one, NR fringes of red. So what we will do now? This Y value I can write as NV, beta for violet. That's NV fringes. Okay, how it is? If suppose this is first maxima, I say this is beta. If this is 2 maxima, then I will say this is 2 beta. 3 maxima, then I will say this is 3 beta. Same way here, NV maxima. So I am writing NV beta ray. Same way for red, NR beta ray. Okay, now what is beta V? Lambda V d by d equal to NR lambda R d by d. This d by d gets cancelled. So we are getting NV by NR equal to lambda R by lambda V. Okay, if I say lambda R is 7000 angstrom and lambda V is 4000 angstrom, and I keep it in this one. This is 7,000, this is 4,000. So this will come 7 by 4. That means 7th fringe of violet or 7th maxima of violet is going to coincide with 4th maxima of red. 7th fringe of violet is going to coincide with 4th fringe of red color. You understand? This is bichromatic. Okay. Now continuing with this only, suppose that we have a source of white light. Now white light source means what? White light source means polychromatic. Polychromatic means what? There are many wavelengths. White light means you can consider that all the colors are there, right from 4,000 angstrom to 7,000 angstrom. So how many wavelengths they are going to emit? Infinite wavelengths. Okay, you can't say only 3,000 because wavelength can be 4,000 angstrom also and 4,000.1 angstrom also and 4,000.11 angstrom also and 4,000.12 angstrom also. So there are infinite wavelengths. Okay, if you say source of white light. So if there are two sources, S1 and S2, they are white light sources, and we want to see the interference. Can we see the interference in this one? Are we going to get the dark and brightness in this particular interference? Answer is we cannot identify dark and brightness because all the colors will be overlapped most of the time. So what is going to happen in this case? Suppose this is the screen over here. At this point, will this be delta x 0 for all the colors? Yes, because the rays are going to travel the same distance. So here delta x is 0, which we call as central maximum. That's fine. But which color will appear? If all the colors are going to give maximum over here, we are going to get a white color. White maximum. Because when all the colors are going to converge, they will give us what color? White color. Okay. Now what is the question? When the white light sources are there on the screen, they are interfering. The question asks you, if detector moves from central maximum position, which color appear first? Okay, which color is going to appear first? Now, what we know, which color is having least wavelength? Violet. Lambda of violet is least. Okay. Then, whose fringe width will be smaller? Now, fringe width, if I talk, it's lambda d by d. Now, this factor is common. So lambda is only the deciding factor over here. So lambda of violet is less. So first maxima of which color will appear first? Violet. Maxima of violet. Where will be maxima of red? Here somewhere. So which color will appear first? Violet or red? Violet it appears, right? No. But answer is red will appear first. Why? Maxima of violet is coming first, there is no doubt about that. But minima of violet also will come first. Yes or no? Minima of violet will be coming first. Minima of violet will be coming at beta by 2. Correct or not? Here is minima of violet. Now what is the meaning of minima? Minima means this color is not appearing. That is the dark of this color. Violet is missing. What is the meaning of minima? Minima means violet is missing. Where will be minima of red? After that. Okay. So here minimum of violet is coming. Minima of violet is coming. That means violet is missing. So when violet is missing, which color will appear? Which color we are able to see? Violet, when we are saying you take entire band of blue. Violet, blue, indigo. Okay. That will all be disappearing at this point. Then which color we are able to see? Red color, because red is not 0 there. What is 0? Violet. So violet becomes 0 here, but red is not 0 here. So what will appear first to us? Red color. So as you move from this point, when the white sources are here, when you move from central maximum, which is having white color, the first color will appear as red. Then violet. Which color maxima comes first? Violet. But which color appears first? Red. Remember that. Okay. So let us see further. Let us see the term that we have not discussed so far is angular width. Angular width of the fringe. Angular width it is, that means it's an angle. Okay, now what is this? It is an angle made by one fringe. Okay, it is an angle made by one fringe. So suppose I am taking this as S1 and S2 to monochromatic sources again. Here I am getting central maximum and here is first maximum. Now what we can say is this is beta, right? So angle made by one fringe is called angular width. That's theta. Theta is your angular width. Okay. So we can say in this triangle tan theta, if I take this as D and this is as usual small d, then tan theta we can write as beta by d. Okay. That's beta by d. Now what is beta? We know that beta is lambda d by d. By d. This d gets cancelled. So what is angular width? Sorry. Lambda by small d. Okay. Now if you know that, suppose that we are seeing this from the eye, you have an eye over here and you want to see with eye. What is the minimum angle that eye can perceive or we can see? Okay, we cannot see all the sizes of the object. Like there are certain objects we cannot see, paramecium we can't see, okay, those small insects we can't see. What is the reason for that? The reason for that is the angle made by those objects or insects on the eye is less than 1 minute. What is resolution of eye? Resolution of eye is 1 minute. 1 minute means what? 1 by 60 of a degree. Okay. If the angle made by an object on the eye is less than 1 minute, your eye cannot see that. Okay. So same thing is over here. The angle also needs to be more than 1 minute. Okay. So how to decide? Can you see that? Lambda by d. We know that d normally we take is very large as compared to lambda, but still we have to take care that it is not less than 1 minute. If it is less than 1 minute, we require certain lenses over here to observe the interference. Able to understand? You need to take the help of a lens, then only you can observe the interference. Angle should not be less than 1 minute if you are trying to observe it with the eye. Okay? So that's angular width. Normally the questions are not asked, but especially they can ask the question, so you remember the formula. Okay. Now we are going to discuss Young's double slit experiment. Okay, YDSE. Though its entire chapter is based on this only, but first we are doing the problems. So you understood what it is. Now we are entering into the experiment. Okay. So Young was the scientist which proved that there is a wave nature of light. And how he proved? By interference. So for interference, what he did and what he said? He said that the two sources that we are taking are coherent sources first. And he took monochromatic sources. Why monochromatic? As I told you in the previous case, that if they are not monochromatic, it is very difficult to find dark and bright zones. Okay, if dark and bright zones are not found, then we will not know that interference is happening or not. As we have seen in case of intensity. Okay, when the intensity is 4i and 0, if that is not happening, we will not be able to identify the interference. That's why monochromatic sources is good. Now, taking monochromatic sources, that to light sources, is very, very difficult. It's not possible to get monochromatic sources. It's not possible to have the bulbs which are coherent also and produce the same wavelength also. It's impossible to get. So then what Young did, he did many times experiment before by taking various kinds of bulbs, various kinds of lamps, various kinds of candles, but he was not able to do. Then finally he decided that he is going to produce two sources from single source only. So what he did, he took a main source over here, okay, and he kept on screen. Okay, and then you put a hole in this one, and from this source we know that its wavefronts will be there, will be going like that. So these two holes were made such that they were on the same wavefront, something like this. Okay, something like this. So this is one hole, and other one is this hole. Now since this hole and this hole are falling on the same wavefront, we can say that this source and this source are vibrating in same phase. Okay, so when they are vibrating in same phase, that means they have same frequency. They will have the same frequency as that of the source itself. Same frequency. Okay, and they are monochromatic also, because I took one source only. This is monochromatic source. Okay, so these two, S1 and S2 also, will be producing monochromatic. Okay, then here somewhere the screen was set. This is anyhow not coming here because there is a screen in this side. So only energy is going through this S1 and this S2 only. Okay, so they will produce their own wavelets. They go like this. Okay, and this will also have. Okay, so like this they are going to produce the interference, and on the screen we are going to see that. Okay, this is what Young's double slit experiment is. Okay, let's see further about it. Let's understand this. Okay, now this is how we produce the two sources. I am taking them directly now. This is S1, this is S2. We take the separation between them is D. Here somewhere is a screen. Okay, if I assume that its intensity is I over here, its intensity is I. Okay, here central maxima we say, here intensity is 4I. Okay, below first, after central maxima comes first minima. So first minima intensity is 0. Then comes first maxima, again intensity becomes 4I, first max. Then again 0. Why? Because this is second minima, this is first minima, this is second minima. Then again 4I. Same way up. This is 0 intensity, first minima, first maximum, that's intensity 4I. Okay, again minima. So like this 4I, 0, 4I, 0, 0, 4I. 0 means basically what? Dark. That means it appears to you black. This will appear to you bright. This again dark. Okay, same over here. This is bright. So there will be alternate strips will be there of bright, dark, bright, dark, bright, dark. Okay, when you saw this one, then only Young concluded that there is interference happening, and he was able to say that it is happening because of wave nature, because interference was associated with waves only. Okay, this way is appearing. Alright, now one more thing we have to see is what is the meaning of slit. Okay, what is the meaning of a slit? Right now what I told you, if there is a screen, you made holes in that. But it is not basically the hole. Initially Young made hole, but later on he said it's a double slit experiment. So what is a slit? Slit basically means if I say there is a cardboard, I take a cardboard over here. Okay, and I take a razor. And with a razor, I cut it like this. Like this. Very, very fine cut. Like this. And again, like this. Okay, this is called slit. This is called slit. Okay, so this one is called as source S1 and this will be called source S2. Okay, so in this one, through this one, the light will be going to the other side. So how many sources will be here? There will be many sources in this actually. Many point sources in this. Okay, they will be vibrating in same phase. Okay, so this is called a slit. Now we are going to see how this interference pattern will be appearing on the screen. We know that the intensity 4I0 will be there. But how will be the interference appearing? That is. See again, this is S1, this is S2, this is the screen, this is 0 max, okay, central maximum, first minimum, first maximum, second minimum, second max. Okay, same way here, first minimum, first max, second minimum, second max. So how will be the interference pattern on the screen? Okay, now this is central maximum, this is minimum. Okay, so maximum, the maximum will be appearing to you like this. This is max. So maximum I am making it like this. This is zero intensity here. This is zero intensity. This is zero intensity. This is max. Okay, and this is only called beta. This is the bright patch. After that, there will be dark patch. Okay, dark patch will be there for minimum. Here is zero intensity. Here is zero intensity. So maximum is here. Again, here is maximum intensity. From here maximum intensity will start. From here 0. This is maximum. So between this maximum again. Okay. So maximum. Okay. Something like this. There will be max. Again here also. So what kind of interference we are seeing? Straight lines. Okay. So bright, dark, bright. Again dark, then again bright. Bright, dark, bright, dark, bright, dark. This way this interference pattern will come. Okay. Wherever there is the maximum, you will be seeing the bright patches. Okay. Wherever will be the dark, you will be seeing the dark patches. Then again bright patches, then again dark patches. Okay. It will come as a straight line. Okay. It will be in straight lines. In this fashion. No problem. Now, if suppose this is not a slit experiment, if I suppose I say that these are pinholes only, these are pinholes, then what kind of pattern will appear on the screen? What kind of pattern will be there on the screen? There is no change in this one on the screen, okay? But what will be the pattern? That we need to check now. Okay, let's see. This is the screen. Okay, now we have to understand what is the difference between slit and pinholes. Slit means is something like this. From here the light is passing. Same way another one is here from which the light is passing. Okay, and here is the screen. Alright, so interference is not happening at one point. Interference is happening at a stretch, just like this, in a slit. Okay, you can say this is a line source actually. What kind of source is this? A line source. What kind of wavefront will come out of that? Cylindrical wavefront. Cylindrical wavefront from here also, cylindrical wavefront from here also. Okay, so when they are going to interfere, they will interfere in this entire zone, like this. So what they will result as? A straight line of same intensity. In which one? In double slit experiment. Understood that? Because it's like this, so wavefront will be going in this way, or wavefront will be going in this way together. Here also. So where they are interfering? They are interfering in this line on the screen also. That's why what was appearing in before case? A line was appearing. A patch. Okay, bright patch. Now if you are having pinholes, one hole is here, one hole is here, and there is a screen. Okay, at central maxima, at one point both have 0 phase difference. But if suppose I take like this, these are the 2 pinholes, this is the screen. Okay. Now, if I come over here, a point over here, now you see, okay, what has increased? So normally beta we write as lambda d by small d. These things are constant, nothing is changing. Okay, and this is d. But if suppose this point here, I am going to move here at this point. Now what is d? Now d is something like this. The distance between the sources and this point is more than d. Yes or no? It is more than d. So if it is more than d, then at this point on this side, beta value has increased. Same way if you go on the back side of this central maximum point, what will happen? Again beta will increase. So because of that, what is going to happen? What kind of shape will come? I'll show you. The shape will be like this, where it will be closest at the center. Center of the screen will be closest. But as you go this side of the screen or this side of the screen, beta value is going to increase. Now beta value means what? The distance between two successive maxima. So at this point, distance between successive maxima less, and at this point, distance between successive maxima is more. So what will be the shape? You come like that. This will be the bright patch. Same way here also. Okay. What are these? The hyperbolic curves. Okay. So if we are having 2 pinholes over here, what kind of curves we are going to get? Hyperbolic. If slits were there, what kind of curves you are getting? Straight lines. Okay. One more case is there, that also we will discuss. Suppose now the 2 sources, pinholes only, are arranged like this. This is S1 and this is S. And this is the screen. Now, what kind of shape will appear at any point? Okay. In this one, suppose this is the point where I am seeing that there is a first maximum. Okay. So here is first maximum. At this point also, there is first maximum. Okay. At this point also, if I can make the distance is same. If I say this point, if I say this is P and this is also P. Okay. If I say S2P minus S1P, it's fixed, it's constant. So this point P, I can take over here also. I can take at the back side also. Okay, keeping this is constant. Okay, keeping this S2P minus S1P constant. So what you can take? What shape you can make? A circle you can make. The circle like this. Correct or not? And make a circle with the same path difference. Same path difference means I am going to get maximum in this entire zone. Same way, I will be getting somewhere here, if it is minima, I will be getting minima in this entire zone. Correct or not correct? So here, what shape I am going to take? I am going to get circular shape. What kind of fringes I am going to get in this one? Circular fringes. In the previous case, hyperbolic, and before that, straight line. In split, straight line. Pinholes, when they are placed perpendicular to the line joining slits and sources and screen, then we are going to get hyperbolic shape. But if suppose the source are along the line joining sources with the screen, then we are going to get circular shapes. Is that okay? That's it for now.